Okay, question 11. So a factory producing plastic gifts for a fast food restaurant, Jolly Meals, claims that 1%, just 1% of the toys are faulty. A restaurant manager wants to test this claim. A box of 200 toys is delivered to the restaurant. The manager checks all the toys in this box and 4 toys are found to be faulty. Identify the type of sampling used by the restaurant manager. Okay, so basically he's got a box of toys sent, and he's just opened the first box that he sees and checks all the toys. This is convenience sampling. He's done nothing convenience. He's done nothing interesting with the sample, except he's just taken the easiest sample he could possibly do, which is taking the first box that gets delivered. So it's just convenient. He's done what is easy for him or convenient for him. Hence convenience sampling. Okay, part B. He performs a one-tailed hypothesis test at the 10% significance level to determine, one-tailed, 10%, whether the factory's claim is reasonable. It is known that faults in the toys occur independently. Write down the null and alternative hypothesis. Okay, so the null hypothesis for these types of tests are that the claim is correct. So H0 is this claim: 1% of toys are faulty. H1, which is the alternative hypothesis, because it's one-tailed, we care that if more than 1% are faulty. He says a one-tailed test, so we know it's either more than or less than, but the restaurant manager, he's just worried that more than 1% are faulty. If it's less than 1%, that's fine. He's quite happy with that. But he wants to test if more than 1% are faulty. So that's H1. Okay, part C. It says find the p-value for the test. Right, now, what kind of hypothesis test is this? Well, it's a binomial hypothesis test. And the reason I know that is because there are 200 toys. So 200 is your number of trials. There's a fixed number of trials, it's 200. And for each toy, there's a 1% chance that they are faulty, that the toy is faulty. And it says here, look, this is the real giveaway. It is known that faults in the toys occur independently. This line here, that we should hopefully recognize binomial distribution, because for binomial distribution, there's two outcomes, so it's either faulty or not faulty, hence binomial. And secondly, they occur independently. So the probability that one toy is faulty is totally independent of whether, the toy beside it is faulty. Okay, so that's the first thing. Then what's the p-value? Well, how many toys were found to be faulty? Well, it was 4. 4 toys were found to be faulty. But because it's a one-tailed test, we're looking at what is a reasonable amount of toys to be faulty. If it's a 1%, if he's saying that 1% are faulty and there's 200 toys, what is a reasonable number of toys to be faulty? So for example, if I said to you 100 of these 200 toys were faulty, is this claim true? Most certainly not. That can't be. You can't have a 1% faulty, yet 100 out of 200 toys are faulty. Something's seriously wrong. So we want to look at what's actually a reasonable number. And the p-value we'll find from finding out what is the probability that x is more than or equal to 4. Because it's not just equal to 4, because that's obviously going to be a tiny number. Well, it's going to be a small number. We want to find what because it's one-tailed, what's the probability that 4 or 5 or 6 or 7 all the way up to 100 are faulty. So how do we do this? Well, we go to, actually let me go back here, menu, probability, distributions, binomial, CDF, number of trials is 200, probability of success is 0.01, lower bound 4, upper bound 200. And it's because 4 were found to be faulty, so it includes 4, so it's between 4 and 100. Press OK, and we get 0.141966, 0.141966, 3 significant figures, 0.142. Okay, finally, part D. What's the conclusion of the test? Well, it was a test at the 10% significant level, and we have 0.142, which is 14.2%. This percentage is bigger than 10%. Therefore, what does that mean? Well, that means that actually it's not that unreasonable that you would have 4 toys faulty. Let's say, for example, though, you checked, let's try 5, just out of interest. If I did 5. Okay, there's only a 5% chance that you'd have 5 or more faulty. So if you had 5 faulty toys, you'd say, no, that's not a reasonable claim. But because we only had 4, it's not unreasonable to that realm. There's a 14.2% chance that the results would be that you get at least 4 faulty ones. So I can't, because it's bigger than 10%, I can't reject the null hypothesis. So we say, therefore, not enough evidence to reject null hypothesis. Okay, and that's it. 7 marks. Okay, definitely not an easy question. The hard bit of this is recognizing that it's binomial. Once you understand there's a binomial distribution, hopefully then it's not too bad. Okay, see you in the next question.